Welcome to Data Structures and Algorithm Design. In this video, you will learn about Introduction to Algorithms. The topics that we are going to learn in this session will be Introduction to Algorithm, Notion of an Algorithm, Fundamentals of Algorithm Problem Solving, and Important Problem Types. Let us start with the need to study algorithm. We have both practical and theoretical reasons to study algorithm. From a practical standpoint, you should know a standard set of important algorithms from different areas of computing. In addition, you should be able to design new algorithms and analyze their efficiency. From theoretical standpoint, the study of algorithm, sometimes called algorithmics, has become a cornerstone of computer science. Let us go to the definition of algorithm. Algorithm is being defined as a set of unambiguous instructions for solving a problem. That is, it has to provide a required output for any legitimate input in a finite amount of time. The notion of an algorithm, which has been depicted in the picture, is for any problem, we'll be designing an algorithm which is being fed to a computer which accepts some legitimate input and produces an output. To illustrate the notion of an algorithm, let us find the GCD of two numbers by making use of three different algorithms. The first algorithm that is being used is Euclids algorithm, second one is consecutive integer checking algorithm, and third one is middle school procedure. Euclid's algorithm for computing greatest common divisor of two positive numbers is given here. As per the algorithm, GCD of m, n is equal to GCD of n, m mod n. This will be repeated until the value of n becomes 0. For example, for computing GCD of 60, 24, it gives us GCD of 24, 12, which in turn will give a value of GCD of 12, 0. In this step, the value of n becomes 0, so it will return the value of n. So the GCD of 60, 24 is 12. In consecutive integer checking algorithm for computing GCD of m, n, the minimum of m, n is assigned to a temporary variable t. We are going to find the value of the variable t which divides both m and n. That value will be returned as the GCD of m, n. As an example, for finding the GCD of 60, 24, the minimum is 24. So we will start with 24 and we will stop at 12 because 12 divides both 60 and 24. So the GCD of 60, 24 is 12. Middle school procedure for computing GCD of m, n is a known procedure. First, find the prime factors of n followed by prime factors of n. Then identify all the common prime factors. Compute the product of all the common prime factors and that will return the GCD of m, n. The example of GCD of 60, 24 is given there, which gives a result of 2 into 2 into 3, which is equal to 12. The important points to be noted from the notion of an algorithm are: each step of an algorithm must be unambiguous. The same algorithm can be represented in several different ways. There may exist several algorithms for solving the same problem, which we have seen for finding the GCD of two numbers. Algorithms for the same problem can be based on very different ideas and they can solve the problem with dramatically different speeds. In this slide, you will learn about fundamentals of algorithmic problem solving. A sequence of steps involved in designing and analyzing an algorithm is given here. First, we have to understand the problem. Then, we have to decide on computational means, exact versus approximate solving, and then algorithm design techniques. Third step is designing an algorithm. Fourth one is prove correctness. Fifth one is analyze the algorithm. And the last step is coding the algorithm. Let us see the fundamentals of algorithmic problem solving steps in detail. Understanding the problem. This is the first step in designing an algorithm. We have to read the problem description carefully to understand the problem statement. Then identify the problem type and use existing algorithms to find a solution. Input to the problem and the range of input has to be fixed. Second step is decision making. In this, choice has to be made on ascertaining the capabilities of the computational device, choosing between exact and approximate problem solving, and algorithmic design techniques. In ascertaining the capabilities of the computational device, if the algorithm is sequential or parallel, based on that we can decide the computational device. Choosing between exact and approximate problem solving, an algorithm used to solve the problem exactly and produce correct result is called an exact algorithm. If the problem is so complex and not able to get exact solution, then we have to choose an algorithm called an approximation algorithm. Example, extracting square roots, solving nonlinear equations, and evaluating definite integrals comes under approximation algorithm. Next is algorithm design technique. Algorithm design technique is a general approach to solving problems algorithmically that is capable to a variety of problems from different areas of computing. So we have to choose the appropriate design technique to be employed for the problem. Third step in algorithmic problem solving is designing an algorithm and data structure. Designing an algorithm is an important step and we have to put utmost care in designing an algorithm, and choice of data structure is also very important because algorithm plus data structure is equal to program. Next, methods of specifying an algorithm. There are three main methods for specifying an algorithm. First one is natural language, second one is pseudocode, and third one is flowchart. In natural language, we are going to make use of English language construct to specify the algorithm. In pseudocode, it is a mixture of natural language and programming language constructs. In flowchart, we'll be making use of diagrammatic representation of the flow of the problem. Next step is proving an algorithm's correctness. Once an algorithm has been specified, then its correctness must be proved. For that, we can use mathematical induction to prove the algorithm. For example, in Euclid's algorithm for computing the greatest common divisor, the equality GCD of m, n is equal to GCD of n, m mod n. This can be taken as the proof of correctness. Next step is analyzing an algorithm. For an algorithm, the most important is efficiency. There are two kinds of efficiency. First is time efficiency, second one is space efficiency. Time efficiency indicates how fast the algorithm runs, and space efficiency indicates how much extra memory it uses. In addition to these two factors, we have two more factors called simplicity and generality. Those two things has to be maintained for analyzing an algorithm. The last step is coding an algorithm. The coding or implementation of an algorithm is done by programming languages like C, C++, and Java. We have to write an optimized code to reduce the burden of compiler. So, if we follow all these steps, then we'll be able to provide a solution for a given problem in a systematic way. Next, let us see the important problem types. All our problem will come under any one of the following categories. The types are sorting, searching, string processing, graphs, combinatorial problems, geometric problem, and numerical problem. To start with sorting, the sorting problem is to rearrange the items of a given list in either ascending or descending order. While doing sorting, two properties has to be maintained. One is in-place property and second thing is stable property. An algorithm is said to be in place if it does not require extra memory. A sorting algorithm is called stable if it preserves the relative order of any two equal elements in its input. Next is searching problem. The searching problem deals with finding a given value called a search key in a given set. Example is linear search and binary search. Next is string processing. A string is a sequence of characters from an alphabet. Searching for a given word in a text is called string matching. These types of problems will come under string processing. Graph problems. A graph is a collection of points called vertices, some of which are connected by line segments called edges. Some of the graph problems are graph traversal, shortest path algorithm, topological sort, traveling salesman problem, and graph coloring problem. Combinatorial problems. These deals with permutation and combination of a subset that satisfy certain constraints. The traveling salesman problem and graph coloring problem are examples of combinatorial problems. Geometric problems. Geometric algorithms deal with geometric objects such as points, lines, and polygon. The closure pair problem and convex hull problem comes under this category. Numerical problems. Numerical problems are problems that involve mathematical equations, computing definite integrals, evaluating functions, and so on. The majority of mathematical problems can be solved only approximately. Hope this session gives the basic understanding of an algorithm. Thank you.